Hello everyone, this is Pradeep. In this video, we will learn about Power Pivot and data models. Imagine that your manager asks for a sales report. The data that is required for this sales report is not in a single table. It is scattered across different sheets. There is one sheet for sales data, another sheet for product information, another sheet for customer data, and so on. So how do you turn all of this data that is scattered across so many sheets, so many sources into one single report? Surprisingly, most of the people solve this simple problem the hard way. Let us suppose we have a data like this which is spread across 5 different sheets. So we have one sheet for sales where we have data at the order ID level. Then we have a sheet for products where we have category, subcategory and brand related information. Similarly, we have a table for customers where we have the gender, age group and segment of each of the customers. And similarly, we have sheets for location and date. Now, what if we are required to do sales analysis at category, subcategory, or at the location level, or at the customer segment or customer age group level? Now, the category, subcategory, customer specific, or the location information is not present in the sales table. To do such analysis, we have to pull the information from other sheets. And this we can easily do using VLOOKUP. In fact sales sheet, we have columns like product ID, customer ID, location ID and date key. So using VLOOKUP, let me quickly pull the data from other sheets into sales sheet and then we will discuss why pulling all the data into the same sheet is problematic and inefficient. So using VLOOKUP, I have pulled the data from other sheets into the sales sheet. We have category, subcategory, brand and unit cost information from DIM product sheet. Similarly, we have gender, age group and segment information from DIM customer sheet, city, state, region, zone information from DIM location sheet, and order date related information from the DIM date sheet. So overall, we have 17 columns that we have pulled from other sheets. In this example, we have only 12,000 rows. If you are working in a big organization like Amazon or Flipkart, where you deal with millions of rows each day, then imagine how inefficient it will be to pull 17 columns of data for millions of rows. Also, here we are working with only 5 sheets. In real life business scenario, there could be 10 sheets or even more. So pulling so many columns for millions of rows is not feasible in real life scenario. As your data grows, the number of formulas used in the data also grow. The workbook slows down, refreshing a report becomes increasingly painful, and suddenly it feels like Excel is not working for you, it is working against you. If pulling all the data in a single sheet is not feasible and is highly inefficient, then how do analysts in big organizations handle millions of rows? Instead of forcing every table into one giant spreadsheet, what if Excel could understand how these different tables are connected to each other? That is exactly what Power Pivot does. It creates a data model where each table stays separate, but they know the existence of each other and they work together. Before we start building anything, let us get familiar with the Power Pivot workspace. Now to access Power Pivot, go to Power Pivot at the top and then from the Power Pivot ribbon, click on Manage. Now this blank sheet that is loaded, this is Power Pivot interface. At the top is the ribbon. This is where you will import data, manage calculations, and access most of the Power Pivot features. This is the data view. Think of it as looking inside each table. We will spend most of our time here while creating the calculations. And this is diagram view. Instead of rows of data, you will see how all your tables are connected together. This becomes the backbone of the data model. And down here is the calculation area. This is where we will build something called measures. They are one of the biggest reasons why different analysts use Power Pivot. We will create our first one shortly and learn why they are so important. So that is all you need to know for now. The interface will make much more sense when we start working on it. So let us bring in our tables and build our first data model. Now that we understand the big picture, let us build our first data model. We will start inside Power Pivot where all our tables will live. So go to Power Pivot and click on Manage. Right now the model is completely empty. If we check the data view, you can see that there is no data. Similarly, if we check the diagram view, it is completely empty. So let us change that and import the data that is required to build the data model. There are two common ways to bring the data into Power Pivot. The first one, and probably the easiest, is when the data is stored in the same Excel workbook. In that case, we simply have to select the Excel table and click on Add to Data Model. So let us check this first method and then we will discuss about the second method. So the first method is applicable when the Excel data or Excel table is stored in the same workbook. Here in this workbook, we have four different tables: customer, location, product and sales. So let us see how to move these tables to data model. This is sales table. To add this table to the data model, we go to Power Pivot ribbon and click on Add to Data Model. See, this simple step adds the table to the data model. We repeat this step with the other tables as well to move those tables to the data model. So now we select the product table and click on Add to Data Model. So we have now two tables in the data model, one for sales and other for product. Let us move the remaining tables as well. So now we have all the four tables stored in the Excel workbook in the data model. We are currently in the diagram view where we can see all the column names in these four tables. Similarly, we can also check the data that is stored in these four tables using data view. So in data view, you can see the name of the four tables: sales, product, customer and location that we have imported in Power Pivot. So here we have imported the data using the first method. This method is quick, simple and perfect for most of the Excel projects. Now we will discuss about the second method. The second method starts inside Power Pivot itself. To get external data, here we have multiple options available. We can import data from database, we can import it from data service, or we can import it from other sources. So if you click on other sources, there are multiple options available. See, there are so many options available to import data from external source. This ability of Power Pivot to import data from external sources or external databases has many advantages. When you are importing data from outside, there is no restriction of 1 million rows. For example, if you are importing data only from Excel file, like we did in method 1, then an Excel sheet or Excel table has the limitation of 1 million rows. What if your original data has more than 1 million rows? When it has 5 million or 10 million rows, then you won't be able to import the data using method 1. Using external sources removes that restriction of size of data. For this tutorial, let us keep the thing simple and import the data from a different Excel file. So we have already imported the 4 tables into Power Pivot using method 1, and the remaining 5th table we can import from a different Excel file. And from the available options, select Excel file and click on Next. Here we need to select the Excel file path. So click on Browse. Our table is stored in Date Excel workbook, so click on Date and click on Open. We want to use first row as the column header, so click on check mark and click Next. So this shows we have successfully imported the 5th table. Let us close the window. Here we can see the 5th table has been imported into Power Pivot. We have imported all the required tables into the data model. So let us now check the diagram view. Here we can see all the 5 tables that we have imported into Power Pivot. But there is one problem. There is no connection between them. Right now, all these tables are just separate islands and they do not know about the existence of each other. So let us connect these tables. To connect the tables, we need something that these tables have in common. For example, if you observe sales table and product table, both these tables have product ID column in common. Similarly, if you observe sales table and customer table, both these tables have customer ID in common. Similarly, location ID is common in location table and sales table. And same goes for date. Date key is common in both the tables. These common columns act as bridges between our data. So let us use these bridges and connect our data. So first we will use product ID to connect sales table and product table. Similarly, we will use customer ID to connect sales table with customer table. Similarly, we use location ID to connect the location table with sales table. And lastly, we use date key to connect sales table with date. Please note the symbols in the relationship. This relationship is called one-to-many. But why this is one-to-many? Why the product side is 1 and the sales side is many? This is because for product table, each product ID appears only once. Therefore, each product ID is unique key for the product table. But for sales table, each product ID can appear multiple times. For example, if a product is sold 100 times, then this product ID will appear 100 times in the sales table, but only once in the product table. Therefore, this relationship is one-to-many. Similarly, each customer ID will appear only once in the customer table, but multiple times in the sales table. Every time a customer buys something, his ID will appear in the sales table. Same for location. After connecting all the tables, let us look at our data model. Now here, each and every table is serving its own purpose, but yet they are all connected. And this is the foundation of Power Pivot. So far, we have connected different tables and formed a relationship between them. Now let us start with the calculations. We will discuss two types of calculations. The first one is calculated columns and the second one is measures. So let us begin with calculated columns. Calculated column in Power Pivot is similar to a new column in Excel, except for one difference. When we add a formula to calculated column in Power Pivot automatically fills the value for each and every row under that column. So it does not matter whether we have 12,000 rows or 12 million rows, Power Pivot will calculate and fill the values for all the rows under that column. So let us see how calculated column works in Power Pivot. In sales table, we have three columns: quantity, unit price and discount percentage. Using these three columns, let us calculate revenue and store it in a new calculated column. So to add a new calculated column, click on add column and then we add a formula for the new calculated column. So when you start entering the column name, you will get a reference to that column name which you can click and enter it. Similarly, select unit price. Now quantity and unit price will give us sales amount, but we also have to subtract the discount also. So multiply it by 1 minus discount price. This calculates our revenue. Let us rename the column to revenue. Now please note that revenue was already present in the table as sales amount and we have added a new calculated column for the revenue. So let us find the discrepancy between these two. So add a new column for the discrepancy. Formula for the discrepancy will be simply the subtraction of these two columns. So if it is 0, then our revenue is correct. So I have added the subtraction of these two columns as discrepancy, and for most of the rows it is 0, barring a few rows where it is non-zero. So let us filter out the zeros and check. See, wherever it is non-zero, the orders were cancelled. So wherever the orders are fulfilled, that is giving us a 0 value, and wherever it is cancelled, then there is discrepancy because the sales amount is 0. Because the products are either returned or the order is not fulfilled, so the revenue is 0. So therefore it is giving us non-zero value. Now please remember this relationship between cancelled and 0 revenue because we will use it while creating the measures. Now let us add another calculated column for profits. But for profits we require the unit cost of each order ID, which is not present in this table. Unit cost is present in product table. See, for each product we have a unit cost here. So let us first add a new column in sales table to pull the unit cost from product table. This we can easily do using related function. So inside related function we add the product unit cost. This will fetch the unit cost from product table. Here we have the unit cost from product table. Let us rename the column. To calculate the profits, we first multiply the unit cost with quantity and then subtract it from the sales amount. So let us add a new calculated column to find the profits. First I multiply the unit cost with quantity and then subtract it from the sales amount. So we have a new calculated column for profits. So far we have created 4 calculated columns for sales check, for discrepancy, for unit cost and for profits. All these calculated columns stores value for each and every row. But what if we want a calculation that does not store value for every row? It calculates the value only when required. In such cases we use measures. Now there are two ways of calculating the measures. The first one is in the calculation area. Calculation area is this empty area that you see under the table in Power Pivot, and the second way is directly in the Excel workbook. So let us begin with the first method, that is calculation area. Hope you remember that we created a calculated column discrepancy earlier, which was the difference between the revenue and sales amount. Both sales amount and revenue represented the same value, that is revenue, but sales amount was the value that was already present in the table and revenue was the value that we calculated using 3 columns: quantity, unit price and discount percentage. That is why most of the values of sales amount and revenue were same. So you can see it is 1430 versus 1430, 1634 versus 1634 and so on. But there was only one difference. Whenever the order was cancelled, then the sales amount value was revised to 0, but because we calculated the revenue basis these 3 columns, the value was non-zero. So therefore you can see that discrepancy is 0 whenever the order was delivered or shipped. It is non-zero wherever the order is cancelled. So we can create a new measure to verify whether for orders where the status is delivered or shipped, there the total discrepancy is 0 or not. So let us create our first measure. We will create our first measure to calculate the discrepancy total using the calculate function. So let me quickly add the formula for calculate function and then we will go through it. First we select an empty cell in the calculation area and then add the formula for discrepancy total in the formula bar. The first argument in calculate function will be the column for which the sum has to be calculated. So we are calculating the sum for the discrepancy column. So it is sum sales discrepancy, and then the second argument will be the condition. Here we want a discrepancy only for the rows where the order status is delivered or shipped. We do not want it for the cancelled because those are non-zero. So let us find out what is the discrepancy total. See, here the value for discrepancy total has been calculated. It is 0. Wherever the orders are delivered or shipped, there is no discrepancy between the revenue and the sales amount. So we can rename the measure to discrepancy total. Now let us add one more measure. We have this calculated column for profits. So let us find a new measure to find the total profits. We select an empty cell in the calculation area, and in the formula bar, we will add the formula for calculating the profits. So here is the total value of all the profits. I have renamed the measure to total profits. Now let us quickly go through the formula of total profits. First argument here is the sum of the column. So here we are adding the values in profit column. So it is sum sales profits. And the second argument is the condition. So we are finding profits only for those columns where the order status is not cancelled. So it is sum of the sale profits where the order status is not cancelled. So far we have calculated two measures, discrepancy total and total profits, using method 1. For calculating the measures using method 2, let us return to Excel workbook. For method 2, click on Power Pivot, and from the Power Pivot ribbon, click on Measures. From the Measures drop down, click on New Measures. Now we want to create measure in the sales table. So table name will remain sales only. For the measure name, let us find the total number of order IDs. So let's rename it to total orders. For description, let us write order ID count. This could be anything that helps you to remember what this measure is all about. For the formula, let us use distinct count. And here we need to put the column name. So column name here is order ID, sales order ID. So the formula for calculating order ID will be distinct count and the column name. So once we put the formula, category will be number because the order ID will be a number, decimal places will be 0, and click on OK. So we have added another measure called order ID, but where has the measure gone? Like the calculation area in Power Pivot interface, there is no area here to check the measure. So to check the measure that we have created, click on measures and select manage measures. Here we can see all the measures that we have created so far. So discrepancy total and total profits were the measure that we created in Power Pivot, and total orders is the measure that we created now using the second method. So to check the total orders, click on total orders and select edit. Here we can check the details of the third measure. Now let us quickly create one more measure. So new measure. We have created 3 measures so far. So let us now create profit per order. For this we will divide the profit measure with the total number of orders measure. So we can divide 2 measures also to derive the third measure. Total profits divided by total orders. This creates our fourth measure. Let's rename it as profit per order. Description we can put anything that helps us remember. So I am putting it as profits. Category will be number, decimal place is 0, and click on OK. Let's check the new measure that we created. Manage measures. See, profit per order. To check the measure, click on profit per order, edit. Here we can check the details of the fourth measure that we created. So we have created 4 measures till now. Discrepancy total and total profits in the Power Pivot interface, and number of order IDs and profit per order directly in the Excel workbook. Now after creating the relationship between different tables, the calculated columns and the measures, let me create a pivot table. So to create the pivot table, select insert. Now instead of a single table, we will select insert pivot table from data model. Let's add the pivot table to the new worksheet. Okay. Now please note here the difference between the regular pivot table and the pivot table of the data model. In regular pivot table, we apply the pivot table to a single table or single range. Here we have all the tables. We are not applying the pivot table to a single table or single range. We are applying it to a data model that consists of all these tables which are connected to each other. Also, we do not have just the columns in these tables. We also have the measures. We define 4 measures in the sales table. See, all those measures are present in the sales table. So for pivot tables, we can use the columns in the original tables as well as the measures that we have defined. We can use the measures not just for the sales table. We can use the measures for attributes of other tables as well. For example, for the total profits that we calculated in the sales table, we can find the total profits region wise also. Suppose we want the total profits for the different states. So we will select state from the location table along with the total profits measures. See, we have the total profit at the state level. Similarly, if we want the total profits by category, we will select category in place of state. Again, category is in the product table. So we will go to product table and select category. We created the measure in the sales table, but we can use this measure for other tables as well because there is a relationship we have defined between different tables. Similarly, not just the defined measures, we can use the columns of one table with the attributes of another table. For example, we can use the revenue, which is the column present in sales table, with the attribute category of the product table. So this is revenue by different category. Similarly, we can find the revenue by customer age group also. Remove category and put the age group. So this is revenue by age group of the customer. Therefore, for data analysis, we do not need to pull the values of one table into another table and create all the duplicate values. So what is making all of this possible? It is not the pivot table. It is the relationships we created earlier. Every time you build a report, Power Pivot follows those relationships behind the scenes, bringing the right information together automatically. That is why we never need a single VLOOKUP, and once the model is built, creating new reports become incredibly fast. Hope you enjoyed the video. Let us quickly recap what all we have covered. We started with separate Excel tables. We loaded those tables into the data model. Then we connected the tables using relationships. We created the measures and calculated columns. And using the original tables, measures and calculated columns, we built a pivot table. And all this without merging different tables or creating a single VLOOKUP. Hope you enjoyed the video. In the upcoming videos, we will learn how to apply the Power Pivot to solve the day-to-day business problems.